The first problem is problem number 61. If 6n is equal to 24, how do we find n? Of course, Jerry Lewis will not hesitate to tell me, because in the previous sections we solved problems like this. So let us write down the equation first. 6n is equal to 24. How do we find n, Jerry Lewis? Good. Make sure that you understand that 6n means 6 multiplied by n. And if we are multiplying on the left-hand side, what do we do on the right-hand side? Yes, we divide on the right-hand side. So we have 6n means 6 multiplied by n. Therefore, if we are multiplying on the left-hand side, what is the opposite of multiplication? Yes, the opposite of multiplication is division, so we are going to divide on the other side. So we are multiplying on the left-hand side. We therefore need to divide by 6 on the right-hand side. So let us divide by 6. N is equal to 24 divided by 6. We have it right there, 24 divided by 6. So our answer is option B. Of course, Jerry is an expert by now on solving problems like these. We call them simple equations. When you get to high school, you will learn that they are called linear equations. So n divided by 5 is equal to 12. So I'm going to sit and wait on Jerry to tell us what to do with that one. Right. We are dividing on the left-hand side, so we are going to multiply on the right-hand side. So just tell me also, why do we need to multiply on the right-hand side? Yes, so we are multiplying on the right-hand side because we are dividing on the left, and the opposite of division is multiplication, so we are going to multiply on the right-hand side. And that is what our statement is saying right there. So let's read our statement. We are dividing by 5 on the left-hand side. We therefore need to multiply by 5 on the right-hand side. And why do we do that? Because multiplication is the opposite of division. Good. So 12 multiplied by 5, and what is that answer? 60. That's correct. I cannot overemphasize the need for every single student at this level to be able to recite, recall, and use the multiplication tables beginning from 2 times and ending at your 12 times table. N is equal to 60, and that represents option D. Good. Here we have another one like it. So I'm not going to put a single thing on the screen. I'm going to depend on Jerry Lewis to tell me exactly what to do. I'll repeat what he says, and at the end, we'll see if he's right. Yes, we have n plus 8 is equal to 48. So what do we do? Right. We are going to subtract 8 on the right-hand side. But give me a reason for that. Why do we do that? Right, because subtraction is the opposite of addition. If we are adding on the left-hand side, we need to subtract on the right-hand side. So let's see. We are going to write the equation first. So n plus 8 is equal to 48. We are adding 8 on the left-hand side, as Jerry Lewis said. We therefore need to subtract 8 from the right-hand side. And the reason that he gave is that subtraction is the opposite of addition. So that is what we do. So n is equal to 48 minus 8. And what is that equal to? 40. That's very good, Jerry. The answer is option A. What about these, Jerry? Do you think that they are easy to work with? Right. Good. Graphs are visual aids or visual description of information. Therefore, we should have no problem working with graphs. As a matter of fact, let's look at our first question. In which month did more boys than girls attend the club? Of course, we should be able to look at the graphs and see the month in which more boys than girls attend the club. We can do that. See, we have it right there already. We can see that the January bar has 15 and here we have 20. So we are sure that January is our answer and that is option D. But we are going to use strategies in order to find our answer. So let us use some strategies. The first strategy will be to construct a table in which each month is shown with the number of boys and girls that attend. So we are going to create a table. So we have the month, we have the boys, and we have the girls. In the month, we are going to write down what month that is. So we are going to do that. Then we look at the number of boys in that month, and we are going to put the number of boys there, and we put the number of girls there. That's no problem at all. So look at January for both boys and girls. Write the values in the appropriate places in the table. So let us look at January. See, the arrow that we have there is pointing in the month. In the table for the boys, it's pointing at 20. And in the table for the girls, it's pointing at 15. So January, we are at January, and we are going to put down for the boys 20 and for the girls 15. So we are going to do the same for February also. What do we have? We have the arrows going across for the month of February, and we have 15 for the boys. And what do we have for the girls? All we have to do is look in this table. We have, in this chart, we have 15 for the girls also. So 15 for the boys, 15 for the girls. So for the month of February, let's put down the values that we have there. So what are we going to do? Of course, we are going to repeat the process for March. So repeat the process for March. Take the arrows from the top of the bar for March. Here is March for the boys. Here is March for the girls. Take the arrows across from the top of the bars and see what happens. So we have here 30 for the boys and 30 for the girls. Good. And of course, we are going to finish up with April. So finish up with the month of April. What do we have? One goes across from the top of the bar in the boys graph to 20, and from the top in the girls graph to 20. So April, 20 for the boys and 20 for the girls. Now the question, let us look at the question. In which month did more boys than girls attend the club? So the month with more boys than girls, look at the table that we have. In which month is the number of boys greater than the number of girls? It is plain to see that it is January, and that is our answer. That is option D. The problem may be solved without the table, providing that the graphs are on the same level. So if the graphs are on the same level, we may progress without using tables. So draw lines across the graph and see for which month the bar in the boys section is higher than the bars in the girls section. So let's do that. Draw a line from the top of the month of January. So we are going to be looking at this month here, and we're going to be looking at January also in the girls. So we're going to draw a line all the way across and see what is observed right there. So let's do that. Good. What do you notice? The line that we have here is going from the top of the bar for January. And it is higher than the bar in the girls graph for January. So we realize here that this one is definitely higher. So the girl's graph shows that the bar is below the line that comes across here. Therefore, we have more boys that attend in January than girls. The line from the boys' graph is higher than the January bar in the girls' graph. January was shown to have more boys than girls. This month is the answer, and this is option D. So that is option D. So we're going to do that for February also. We're going to draw a line from February in one graph to February in the other graph. What do we notice? We notice that they are on the same height. So the line shows that the attendance in this is the same for both boys and girls for the month of February, because the line goes from the top of the bar in one graph to the top of the bar in the other. And let us also do the same for March. What do we notice? That the line goes from the top of the boys' graph to the top of the girls' graph. So we are sure that they are on the same level. So the attendance for the month of March are the same. Finish up with the month of April as usual. Goes from the top of the month of April in the boys' graph to the top of the month of April in the girls' graph. And we realize that they are also equal. So April also has the same number of boys and girls. The month with more boys than girls is January, and this is option D. Good. In which 2 months did the same number of girls attend the club? So let us see what the instruction says. The question requires that we focus on the girls' graph, because it says, in which 2 months did the same number of girls attend the club? So we are going to be focusing on the girls' graph. Find the 2 months in which the bars are on the same level. Is there a situation that we have the bars on the same level, Jerry? Make sure that you are paying attention. Right there. The 2 months are January and February, and the correct option is A. See, we have these 2 months as shown right there on the same level, and January and February, they are representing those 2 months, so we are sure that option A is correct. How many girls attend the club in April? What do we do? The question also requires that we focus on the girls' graph. Trace the line from the top of the bar in April to the numbers on the attendance axis and take note of the value. So we are going to say, we are going to answer the question, how many girls attend in April? Go to April. Go straight across. So that's it. 20. So we have 20 girls. Notice that we are going from the top of the month of April straight across, and it reaches what? 20. So because it is at 20 right here, the answer is option D, 20, and 20 is option D, so that's our answer. In which month was there a difference in the number of boys and girls who attended the club? So which month was there a difference? Of course, we can go back to the table that we used before. We should be able to look up at the graph and answer the question. So of course, we should be able to look at the graph and answer the question. However, we are going to use some strategies just in case we need to be 100% sure. Construct a table in which each month is shown with the number of boys and girls that attended. So look at January for both boys and girls. Write the values in the appropriate places in the table so that we have for January and we have the two arrows there, and one is at 15 and the other is at 20. So January, 20 for the boys and 15 for the girls. This is a table that we have constructed before. So we are going to do the same for the month of February. That's the month, and those are the numbers. We continue to repeat for March. Notice where the arrows are pointing. They are pointing on 30 on both graphs. So for the month of March, we have 30 for boys and 30 girls. Finish up as usual with the month of April. April, 20 boys and 20 girls, and we can see that from where the arrows are pointing. Only January is the number of boys greater than the number of girls. The answer is option A. See, we have here April, they are the same, March the same, February the same, January. So in January, they are different. The number of boys is greater than the number of girls. The mean score in 20 games is 5. What is the score overall? The mean of a number of scores is equal to the total. So it's the total score divided by the number of scores. So let us write this in a formula. So the total score over the number of entries is equal to the mean. Now, it says the mean is 5. So where we see the mean, we are going to put 5 right there. And the number of entries, since we have 20 games, so the number of entries is 20. And what does the total score mean? Which, can you tell me now, what word in here could give you the idea, same idea as the total score? What would mean the same as total score? Right, Jerry? That's the score overall. That is the total score. So the total score divided by the number of entries is equal to the mean. So the question requires the overall score, which is the total score. We know the mean is 5 and the number of entries is 20. So we substitute them into the equation. So where the mean is, we put 5, and where the number of entries is, we put 20. We are dividing by 20 on the left-hand side, so we multiply by 20 on the right-hand side. So the total score is equal to 5 multiplied by 20. 5 multiplied by 20 is equal to 20 multiplied by 5. So although here we have 5 multiplied by 20, here we have 20 multiplied by 5, they are the same. And the answer is option A. The order in which we multiply numbers does not affect the result. So 5 multiplied by 20 is equal to 20 multiplied by 5. We therefore say that multiplication is commutative. So that is the word that we use if the order in which we do our operation does not matter. If it does not affect the result, we say that the operation is commutative. This is a very interesting one. The marbles in a bag are 5 red, 6 blue, and 4 white. What is the probability of selecting a blue marble on the first try? On the first try, so let us do that. The probability of an event happening tells us how likely it is that the event will happen. It is measured on a scale from 0 to 1. Probability 0 means that it is impossible for the event to happen. So if the probability is 0, the event will never happen. A probability 1 means that it is absolutely certain that the event will occur. The probability that an event will occur is given by the formula, and the formula is right there, and it looks very long and very wordy, but it's actually very simple. Probability is equal to the total number of events that will give a favorable outcome divided by the total number of equiprobable events. That's a new word, equiprobable. So we need a blue marble. Therefore, any blue marble will give a favorable outcome. So any blue marble will give a favorable outcome. There are 6 blue marbles. Therefore, the number of events that will give a favorable outcome is equal to 6. They are 5 plus 6 plus 4, which is equal to 15. So we have 15 marbles in all. Each marble has an equal chance of being selected. The total number of equiprobable events is therefore 15. Therefore, what do we say? The probability is equal to 6 over 15, or 6 divided by 15, or 6 fifteenths. So the total number of events that will give a favorable outcome is 6, because we need a blue marble, and we have 6 blue marbles. The total number of equiprobable events is equal to 15, because when we add all the marbles up, we get 15. So our probability is 6 divided by 15. There we have it, 6 fifteenths. However, that is not one of our answers. So we may reduce the fraction. The answer is not there, so we reduce the fraction by a factor of 3. So what number can go into 6 and go into 15? Also, that number is 3. Therefore, we are going to reduce the fraction by the factor 3. So we are going to say 3 into 6, and that is equal to 2, and 3 into 15, that is equal to 5. So our answer is 2/5. The answer is option C. In an ordered set, the middle number is called the median. The answer is option C. There we have it. What about the other options? The mean is found by dividing the sum of the entries by the number of entries. The mode is the entry that occurs the most times. The range is found by subtracting the smallest entry from the largest entry. Which chef used less than 50 pounds of rice? Of course, this table is showing the chefs and the amount of the products that they use. So that is our table. So if we look in the table, we will see the name of the chefs and the products that they use Also, we will see the amount of products that they use. And all the amounts that we have there are given in pounds. So our first problem is, which chef used less than 50 pounds of rice? Jerry, what do we do? Take a look at the column with the rice. So we're going to look in the rice column. We need to know which one used the least amount of rice. Which one used less than 50 pounds of rice? So look at the rice column and see if we can identify the number that is less than 50. What number in that rice? So we have 125, 105. Which one is less than 50? So identify the smallest number right there. And what do we do with that small number? We put an arrow to identify the associated chef. So what is that chef? That chef is ram goat liver, and he is given option A. What is the total amount of flour used by the 4 chefs? So we're going to look at the column that contains flour. So look at that column and add the numbers in the column. So we have, in there we have 90, 35, 20, then 20. So when we add them together, we get 165 pounds. So this is option D. Who used more sugar than flour? How are we going to identify the chef that used more sugar than flour? So let's see. Good. So we are going to highlight the columns with the flour and the sugar, and we are going to look in which one or in which section we have what? More sugar than flour. Is it this one? No. Flour is more. Is it this one? No. Flour is more. So identify the row in which the amount of sugar is more than the amount of flour. That's it. Identify the chef which the row pertains to. Good. So that chef is Fat Fred. So Fat Fred is the one, and that is represented by option C. So there we have it. It is represented by option C. So this question is asking, who used the least amount of products? So what do we do then? To find out who used the least amount of product, let us go to John Bull first, and we are going to add and find the total of the product that is used by him. So we are going to add it 125 to 90 plus 35, and that is equal to 250 pounds. We are going to do the same for Belly Jean. Belly Jean has 105 plus 35 plus 15, and that is equal to 155 pounds. Fat Fred, we are going to add again 50 plus 20 plus 25, and the last, and it would appear to me to be the least, ram goat liver, and he's using 35 plus 20 plus 15, and that is equal to 20 pounds. 70 pounds. So what do we say then? Identify the smallest total. What is the smallest of all the totals that we have here? 70? 70. And that belongs to ram goat liver. And that one is option D. Now here we have another pie chart. And this pie chart shows some items in a grab bag. Recall the formula for probability. Of course, the question is number 75 and it is asking us, what is the probability of selecting a chocolate? So let us read the question thoroughly. In choosing a single item from the grab bag, what is the probability that it is a chocolate? So what is the probability that it will be a chocolate? How do we work that out? So we are going to put the formula again. The probability, and there's quite a bit of formula. It says the total number of events that will give a favorable outcome over the total number of equiprobable events. And of course, we know what the word equiprobable means, right? It has an equal opportunity of being selected. So the total number of events, how do we find that? We need to look in the chart and identify all the chocolates. So we need the probability of selecting a chocolate. The chocolate is our favorable outcome. So because the chocolate is our favorable outcome, we need to determine the number of them. So we have that statement that says that there are 2 of them. The pie chart is divided into 8 equal parts, each of which has an equal chance of being selected. The total number of equiprobable events is therefore 8. So the probability of selecting a chocolate is 2 out of 8, and this is option B. The other question is also based on the previous pie chart, and we have it right there. It says, what 2 items had equal chances of being selected? So we may not need to work out the actual probability on this occasion, as it is not a requirement of the problem. So we do not need to work out the probability at all. Write down the number of each items. Chocolate. How many chocolate do we have? 2, as we can see. Right, Mr. Lewis? We have 2, as we can see, because we have them highlighted there. So we need to move on. Write down the 2 for the number of chocolate, and we move on to stone. Jerry, make sure you don't grab a stone when you are grabbing an item from that bag. You probably want something that you can eat, like cherries or candy. So how many stones? Look very carefully. Good. And we have them identified right there. So we have 3 stones. So we write them down. And it is easy to tell the number of the ones that we have left, because all the others are highlighted except those 3. So how many candies do we have? Good, 2. And they are highlighted right there. So we write down the 2. How many chairs do we have? 1. So that's it. Now let us revisit the question. The question says, what 2 items had equal chances of being selected? So all we need to do is look down here and see the ones that are equal. And what are the ones that are equal? Chocolate and candy. So what option says chocolate and candy? B. Good. So that's the answer. So it can be seen that the 2 items with the numbers equal are chocolate and candy with 2. The answer is therefore option B, and we have it highlighted right there. Now, what can be concluded from the pie chart? We have a lot of statement there, and the pie chart has a lot of information in it. So if we could take an approach that we could simplify the whole situation, then that would be a very good thing to do. Let us use the number of each items in the bag from the previous question. So we are going to put them down again. There we have them highlighted, and there are the numbers. So let us take the statements one by one. Option A, the bag contained 3 stones and 2 chocolates. The number of stones is greater, not fewer. So option A says the bag contained fewer stones than chocolate. Is that true? Do we have fewer stones than chocolate? How do we know that? Good, right. So we have 3 stones and 2 chocolates. Therefore, we have more stones than chocolate, and that answer is not correct. So let us move on to B. Do we have more chairs in the bag than any other items? So we say more chairs were in the bag than any other item. Do we have more chairs than any other items? How do we know that? Because we only have 1. So we only have 1 chairs. Therefore, we cannot possibly have more chairs than any other item. So it says there, the item that occurs the most is stone. More chairs are not present than the other items. Option B is incorrect also. So let's go right there. Fewer chairs were in the bag than any other items. Do we have fewer chairs than any other items? Do we have fewer chairs? Right, because how many chairs do we have? Right, so we have 1 chairs and we have more than 1 of the other items. So option C is correct. We have fewer chairs than any other items. Okay, let us look at the last one. Although we know the answer, let us make sure that D is also incorrect. The bag contained more chocolate than candy. What do we say? How many chocolate do we have? 2. How many candy? 2. So do we have more chocolate than candy? No, we do not. Because the number of chocolate and the number of candy, they are equal also. Now, the graph shows the earnings of a company in thousands of dollars. That's what the graph is doing. So, in which 2 months did the company earn the same amount of money? So let's go again. In which 2 months did the company earn the same amount of money? Which 2 months? Right, Jerry? That's July and August. So let us put, see, they are on the same height and we have them highlighted. So we have no problem. Look for the 2 bars that are on the same height. Those will represent, what is the answer? We do not need to use the arrow in this case, Jerry, because we are not required to tell the amount of money that is earned. Okay, so we only need to tell if they are on the same height, which means we are determining that the same amount of money was earned in those 2 months. So look for the 2 bars that are on the same height. July and August. And what option is that? B, option B. That's correct. They are the months July and August. The option they represent is B. Good. What was the total earnings for the company in the 5 months? So how do we tell that? Now we are looking at the earnings. What did you do in the last question? But we are looking at the total earnings. How are we going to tell the earnings? Find the value of the earnings associated with the height of each bar. Good. So, right. No, do one at a time. Let us do one at a time. So we are going to start with the month of May. So we are using May, and the arrow goes across, and it is at 5. Good. Right. So we may move on to June. The arrow goes across 15. Right. So what about June? Right, 15. Good. So what about July? Okay, 20. Can we take July and August together? So we are at July. So instead of taking July by itself, we realize that July and August are on the same level. So we can take them together. So what is the number for July? 20. If they're on the same level, what is the number for August? 20. Good. So we need to determine the total earnings. So, oh, we didn't do September yet? Okay, good. So let us do September. And what is that? Good, 30. So 30. All right, so let us add now. The total turns out to be 90. Right, good, good. So 90. But let us see what the 90 means. The graph shows the earnings of a company in thousands of dollars. Right, Jerry? So the 90 represents 90,000. So the answer is 90, but the graph represents the earnings in thousands of dollars. The total earnings is therefore $90,000. And that option is option D, right? Good. From the information on the graph, what statement is true? So let us take the first statement. The company earned the same each month. But does the company earn the same each month? No? How can you tell that the company? All right. So all the bars are not on the same level. So that is how we know. Good. What about B? The earnings of the company were different each month. Are they different every single month? No, they are not different every single month. At least in July and August, they are on the same level, so they are not different for every single month. Because we have these two that are equal, so option B is incorrect. So what do we say now? C, the earnings decreased over the period. How do we know decrease? If by going across like this, it keeps going down. Does that represent a decrease? Do we have them going down? How do we know? Right, right. So we have them getting higher all the time. And the last one is the highest. So we are sure that it's not decreasing every month. It is true that the earnings are the same for 2 months. This option is correct. So we have B, the earnings were the same for 2 months. Can we identify those 2 months? Good. That's not difficult for you to do because we have them highlighted already. Good, right. Now, I hope that for this one, not only Jerry Lewis, but the other students will realize that what we are using is a process of elimination. We take each option and we examine the option against the information that we have in the graph. This process of elimination is one of the most important aspects of solving problems in multiple choice. So, Jerry, when you are not sure of the answer, by working it out, you may use that process of elimination. The process of elimination eliminates all the incorrect answers, and we are only left with the correct answer. Thank you, Jerry. We are at the end of section D and also the end of practice paper number 1.